This is the Fender Champion 600 amplifier. There's a couple of versions of this amplifier. There's the originals that are hand wired, go for $2,000 plus. And then there's this version, which is made in China. It's got a PC board, cheap components. Sounds pretty good. They do break a little because of the caps. Cap values are not high enough, and I think the bias is slightly hot, but Fender love to bias things hot because hot sounds good. So we're going to actually do a lot of things. This change the speaker, change the grill, put an effects loop in, add a Dumble preamp, Dumble style FET preamp inside the amplifier as well, and rebias and just make it sing. So let's do it. Let's take it apart and I'll show you how and what we are going to modify. This is what the amplifier looks like inside. Power section, power supply section, I should say, power amp section, tone stack, preamp, input board, 2 inputs, and the input board also carries the volume pot, which goes between the 2 stages of the 12AX7 tube, and then that's connected via this ribbon cable here. This is the output to the speaker, so that'll stay. Everything here will stay. The switch is a good switch, and this LED light will stay. But the first thing we'll do is replace the power section with something much more beefier and robust. And so it's got some good filtering on it. F&T caps, high voltage, so that'll increase the life of the amp because it doesn't have a standby switch. And then the power section is going to be point-to-point hand wired. It does get hot, so I don't want it near any PC boards. And then over the closer side, the preamp section gets replaced by a new board. And this board has a different tone stack. It's just a single capacitor, which is what a 5E1 has. But then I've also added a Dumble FET input stage, and we'll switch that FET input stage by making this a push-pull. So it'll be a volume and a switch to switch in the Dumble FET, or not, or just use the regular preamp stage as well. And the final addition to the amplifier, because we've got a lot of space here, is I'm going to put in an effects board, effects send return board as well, and drill some jacks out here so I can have send and return, and then this board will do the attenuation and reamplification, and then it'll feed directly into the power amp tube. So I think this is going to be a great build. I'm really looking forward to doing this for a long time, and I know it's going to sound good. So let's get on with it. So we've removed the board. So this is scrap. I might salvage some parts off it. And first thing is we're going to do is put this board here. So we're going to load this board up with some components, higher quality components than the original. And then this board's going to go here. And so then we're going to have the preamp and the power supply. I'm going to hand wire the output tube. It's only a single-ended amplifier, Class A operation, so there's not much to it actually, apart from a couple of resistors and some capacitors. So that's going to be a hand wire. Key thing first of all though is to get this power supply all wired up and insert it in the board and test it and see if it works. I've got a function generator here that's feeding a 60 Hertz sine wave into the input of the power supply board, and then I have this on B+1, so the first power output or voltage rail of the power supply. And so I'll switch on the signal generator or the function generator, and you can see, so this is the signal generator set to 10 volts peak to peak, and what we're seeing there on the oscilloscope is a DC level of about 10 volts. So that looks good. What I'll do now is go to channel 1 and AC couple this guy. So now we have a capacitor. So the only thing that's getting through to the oscilloscope are transient signals, signals that don't have a DC level, and this would be our hum or our noise that we're interested in. I'm just going to adjust the sensitivity of the scope. Yes, we can see something there. That does look like a little bit of hum. It's very low, but it's something that we might be able to hear. So we probably want to think about how we can suppress that. Let's go to B+3. Oops, there as well. And B+2. So that is interesting. What do we have it set to? 20 millivolts per division. So there's about 20 millivolts of signal there. With the scope probe just floating, I think we're picking it up from somewhere. I think it's an outside signal interference. Okay, now the high voltage is hooked up, and we're on the last filter cap with the power supply currently reading just a few millivolts. I have, and this is my discharge ready for when we have finished this test. So this is a nerve-wracking part, so I'm going to plug it in. No explosion. Move over to the voltmeter. So unloaded, we're looking at 417 volts of DC, so that feels good. Not sure I can measure that on the oscilloscope. I have to check the oscilloscope specs. The circuit seems to be functioning okay. Most importantly, we've got to be very cautious and just make sure we discharge this whole thing. So I'm going through 800 ohm 5-watt resistor down to ground, and this is my probe, discharge probe that I made. It's an old multimeter probe with a big fat resistor and a crop clip taking it to ground. Now it looks discharged. I've completed hand wiring the power section now. It's looking good. And I just turn the master volume up. I got the master hooked in here. And I've just got a signal from the signal generator coming in. So if I just turn up the master, it's looking good. This is the preamp board with FET Boost complete. So let's do some testing here on the scope. We'll do it without the FET boost. Looks good. And then we'll add the Biased FET Boost, and we'll see clipping earlier. It's fantastic. Okay, now let's screw in the effects loop. Next, we're going to trim up the effects loop. So this is the signal going in to the effects loop. You can see it's plus or minus 3 divisions on the oscilloscope. So let's see if we can get the same signal quality on the output of the effects loop. We are on the output now of the effects loop. I'm going to just trim this up so we get the same. So that's 3. So that's a zero sum. So that is plus or minus 3 divisions, vertical divisions on the scope. And I'm not seeing any clipping. So that is a nice, clean 1 kilohertz signal. No degradation in signal quality or amplitude. Fantastic. I think it's time to plug this thing in.